Hi everyone, this is David Louie here, and I'm going to be teaching you guys how to draw planes and directions in unit cells, specifically in crystal and hexagonal. And I decided to do this because I myself and a lot of other fellow students struggle sometimes conceptualizing this, because this is one of the more important things to know and learn for material science, but it also can be difficult to conceptualize. There are a lot of different rules and stuff, so I just thought I'd make this video, and I hope you guys learn something from it. So we'll start off easy. We'll start off with the unit cell for crystalline structure. So for the first example, we're going to draw the direction 2 bar 0 in the unit cell. So it's actually really straightforward. All you've got to do is you've got to understand that the first element in the matrix represents your x, the second is y, and the third is your z. So if you have your x, y, z axis drawn, all you've got to do is just really just put the vectors onto the respective number points on the axis. So to make it a little bit simpler, I usually like to take out a scalar and deal with numbers between 1 and 0, since we're dealing with a unit cell with lengths of 1. So in this case, 2 bar 0 would also equal 1 bar 0. And of course, 1 bar being -1. So now we have 1, -1, and 0. So all you've got to do now is just see that your first vector x goes 1 in the x direction, and then it goes -1 in the y direction. This is y, so -y is this way. And then it goes 0 in the z direction. So this would be your end vector. However, we do want to include the direction inside the unit cell. So it is also correct to actually, it's correct to shift over the vector by 1 unit so that you can keep it in the unit cell. So if it was to the left, we'd shift it. If it was to the right, we'd shift it to the left. But in this case, it would be here. So we would shift it 1 to the right, which would give us this direction right here. So again, quite straightforward. You just pretty much put them into numbers between 0 and 1, draw them out, and put them in the unit cell. Now for planes is a little bit more difficult, not too much. The only thing that you really have to remember is that when you're dealing with planes, you have to take the reciprocals of the numbers in the brackets. So in this case, we have 2, 2, 0. And so our reciprocals will form half, half, and infinity, right? Because the reciprocal of 0 is going to be infinity, okay? So now what we got to do is just go to the different axes and plot these points. So for the x-axis, half, if this is one length, half is going to be right in the middle. Y is also going to be half, so right in the middle. And z is infinity, so you may be confused, what does that mean? Well, what infinity would represent in your plane is that the plane is completely parallel with the z-axis, meaning it doesn't touch the axis at all. So it's simple. All you have to do is just connect these two lines and then try and envision a plane that's completely parallel to the z-axis. So you draw lines that are parallel to the z-axis, so straight up, and then you just connect them right there. So that is pretty much how you do planes and directions in crystalline unit cells. Now moving on to hexagonal. Hexagonal, for directions, there are two very distinct methods. One is your projection method, and the other is your vector addition method. So both have their own flaws, but you may have to choose between one of them. So it's good to know both. So for your vector projection method, how you start off, we're going to start off by drawing the direction 1 bar 0 and 2. So what I like to do is I like to convert all my drawings into a 2-dimensional representation and then convert it into 3-dimensional, because that kind of helps me with what I'm doing. So in this case, we start off with a 2-dimensional. We have 1 bar 0, 2. We take out a scalar to make it smaller numbers, so we have -1/2, 0, and 1. We just divide everything by 2, okay? So In crystalline cells, you have your X, Y, and Z as the areas of the matrices. But for this time, when we're dealing with hexagonals, we have A1, A2, and Z. That's how it works. So the first number corresponds to numbers on the A1 axis, second one the A2, and the third is your Z axis, which is this vertical one. And so to find your 4 Miller index notation when you're dealing in the projection method, all you have to do is if this number is U and this number is V, and T is your A3, T is equal to negative U plus V. So in this case, it would be negative 1 plus 0, which would make a positive 1. So your 4 Miller index notation would be 1 bar, 0, 1, 2. Okay, so now that we have this, okay, we have a 4 index right here. All we've got to do now is just look at the corresponding axes and plot. Okay, so we're going negative half in A1. So if we start here, negative 1 in A1 goes down to here. Okay. If we go 0 in A2, it just means 0. In A3 is positive half. A3 is going this way, so positive half gives you right about there. And in Z, we're going up 1. But for the 2-dimensional, it's all on the base. So Z is just going to be 0 for now. Okay. So now you just have to decide where these two meet. Okay, so the easiest way to do this is just to simply draw lines perpendicular to these points. So if I draw one line here, and I draw one line here, they meet at this point. Okay, my drawing isn't as great as it could have been, but it's somewhere about right here. Okay, so all you have to do is then just finish up your line, and that is your direction. Now in 3 dimensions, you're going to have a Z, it's going to have a Z component of 1. And of course 1 being the top of the surface. So if it's going to go right about here, up in 1Z, then in total it's going to look like this. So that is your direction for the projection method. So moving on to the vector addition method. The vector addition method is a little bit more tedious to find the 4 Miller index, but it still can be done with the 3 Miller index, the 3 number index that you're given. So 1 bar 0, 2, you have A1, A2, A, and Z. So it's a little bit more straightforward. So all you do here is just you follow the numbers on the axis. So A1 is going to be negative half, and so negative half would be here. A2 is going to be 0, which is nowhere, and Z is just simply 1. So on the same drawing in the 2 dimensions over here, this is what you would have right here. It's a little hard to see, but notice how these two are different from each other, which is why these two methods are very different. So if you were to actually draw this out, and it would look something like this. And that is really it. So it's a little, so the vector addition method is easy to draw. It's a lot harder to get the 4 Miller index notation because you have to use all the formulas, but we're not going to look into that right now. And finally, to end off the video, we're going to look through planes in hexagonals. So once again, you start off by getting your reciprocals. So in this case, the reciprocals would be 1, infinity, and half. Now, again, this is for A1, A2, and Z. So for your third component, the A3, it's the same. It's negative U plus V. So in this case, 1 plus 0 is 1. So negative that will give you a negative 1. So really, you have a 1, 0, negative 1, 2. And then now that you reciprocate that, you get 1, infinity, negative 1, and half. So now, all you got to do is just find the points on the axes with these corresponding numbers and draw your plane. So for the A1, I didn't label my axes over here, but this is going to be A1 right here. This is A2. This is A3. And this is Z. So for A1, you go 1 in the A1. And so this is a unit length of 1. So you put a little circle right there. You're going to go 0 in the A2. Well, infinity rather, because you're not going to touch the A2. In the A3, you go -1, which means if you draw an imaginary line back here, you get this point. And then for your Z, you get half, which means it only goes halfway to the top of this entire unit cell. So it'll probably be somewhere around here. And so then from here, you just connect these dots, almost like a little triangle, and that is your plane. And you can double check because you know that the A2 axis is right here, and this plane does not touch the A2 axis at all because the number here is infinity, and so it does not touch the axis. So that's all it is. It's straightforward if you just draw it out and you just really follow all the algorithms that you're given. So thanks for watching, and I hope you learned something.